Hi class, welcome to exercise 3B, adding and subtracting surds. This class will be a small extension of our first one about surds, as will the following two after this. So this means it will be a quick video, I think, but there's still a fair bit of pre-learning for you. So let me introduce the examples and pre-learning attached to that. Okay, so example 4 is adding and subtracting surds. And the pre-learning in the new book is questions 1, 2 and 3. And in the old book, it's questions 5 and 6. Then we have one more example, and that's example 5, which is simplifying surds to add or subtract. And the pre-learning for that example is questions 4 and 5 in the new book and questions 7 and 8 in the old book. So as you can see, there is a fair bit of pre-learning there. So having said that, some of you might be really comfortable with these concepts already, especially those of you who have been in a pre-methods class before. If that's you, by all means skip this video, but make sure you still complete the pre-learning. You should also check the bottom of this OneNote to see if you've already learnt the skills that you would have to consider this lesson a success. You might also want to check the learning intentions in your textbook. Okay, let's get on with the introduction. In the last lesson, we learnt that multiplying two square roots together is the same as the square root of those two numbers multiplied together. So the square root of a times the square root of b is equal to the square root of a times b. And of course, this goes back the other way as well. In this lesson, we're going to ask the question, is the sum of two square roots equal to the square root of the sum of those numbers? In other words, is the square root of a plus the square root of b equal to the square root of a plus b? So to test this out, let's just try one simple numeric example. And there's nothing simpler than the square root of 1 plus the square root of 1. And that's because the square root of 1 is 1. So now we have 1 plus 1, which equals 2. So the square root of 1 plus 1 is equal to the square root of 2, because I'm sure you agree with me that 1 plus 1 is equal to 2. And we all know that the square root of 2 is definitely not 2, because 2 squared is not equal to 2. So we can see from just one example that the square root of a plus the square root of b is not equal to the square root of a plus b. In fact, this is true for all cases other than both a and b being 0. But we know that x plus x is equal to 2x because we've covered like terms in great detail already. So what if x was equal to the square root of 2? Well, then x plus x equals 2x would become the square root of 2 plus the square root of 2 equals 2 times the square root of 2. Because all we've done here is substitute in square root of 2 for x. And something that's a little more complicated than 1 plus 1 is 4x plus 7x equals 11x. And if we were to substitute in that x equals the square root of 2, that would become 4 times the square root of 2 plus 7 times the square root of 2 equals 11 times the square root of 2. And just like all these are like terms, we call these two lines like surds. Also, with what we know from the last class, we can be on the lookout for sneaky like surds. And from our last class, we know that if b was equal to c squared times a, then the square root of b would equal the square root of c squared times a, just by substituting in the value we've given b. And we learnt that that was equal to c times the square root of a. So using this same value of b, if we were asked to add the square root of b plus the square root of a, then initially they don't look like surds, but then substituting in the value for the square root of b that we've already worked out, that's now equal to c times the square root of a plus the square root of a. We have c times the square root of a plus 1 times the square root of a, so that's equal to c plus 1 times the square root of a. So that's because we found our sneaky like surds. So before we finish the introduction, let me just give you one numeric example. So let's remember that the square root of 8 is equal to 2 times the square root of 2. Then if you were given a problem that said 3 times the square root of 2 minus the square root of 8, then we can substitute in 2 times the square root of 2 for the square root of 8, and that now becomes 3 times the square root of 2 minus 2 times the square root of 2. Because as we know, the square root of 8 is 2 times the square root of 2. And now we've got some like surds, and now we have 3 times root 2 minus 2 times root 2, so that's equal to 3 minus 2 times root 2, which is the same as saying 1 times root 2 or root 2. Okay, so that's one numeric example. I'm going to leave the introduction there, and because this is such a quick lesson, I'm going to leave the formal definition of the rules that we're going to be using in the sections that we will be using them. All right, I'll see you in the next section. Okay, in this section we'll be adding and subtracting surds, but let's summarize the rules that we discovered in the introduction that we're going to use in this section. So they are, while the square root of x plus the square root of y is not equal to the square root of x plus y, if x and y are different numbers, we can still add a times the square root of x plus b times the square root of x, and that's equal to a plus b times the square root of x because of like surds. And just to be clear that subtraction and addition are the same thing, if we had a times the square root of x minus b times the square root of x, well, that would equal a minus b times the square root of x, also using like surds. All right, so let's remember that fact, write it down if you need to, and let's get on with the example 4. In part A, they're asking us to add 2 times the square root of 3 and 4 times the square root of 3. So this is really straightforward. I've got 2 of root 3 and 4 of root 3. 2 and 4 of anything is 6 of that, right? There's really no working out to do here, but just say that that is 6 times root 3 using like surds. Okay, part B is a little bit more challenging because the expression here is 4 times the square root of 6 plus 3 times the square root of 2 minus 3 times the square root of 6 plus 2 times the square root of 2. So we've definitely got some surds here that are not like surds, but I've got 2 coefficients for the square root of 6 and I've got 2 coefficients for the square root of 2. So just for today, I'm going to line them up, okay? So that will mean that I've got 4 times the square root of 6 minus 3 times the square root of 6 and 3 times square root of 2 plus 2 times square root of 2. So now we've got 2 different cases of like surds. So the coefficients of root 6 are 4 and minus 3, so that's 1 times the square root of 6, which is just the square root of 6. And the coefficients of square root of 2 are plus 3, plus 2, so that's plus 5 times the square root of 2. And we can't go any further than that because these are not likes. Well, we could if you wanted to separate out root 3 and root 2 for the square root of 6, but we don't need to. All right, at this point you should pause the video and get on to your pre-learning. That's questions 1, 2, and 3 in the new book, and questions 5 and 6 in the old book. All right, and I'll see you back in the next section. In this section, we're going to simplify surds to add and subtract. So as we said in the introduction, sometimes the square root of x and the square root of y are sneaky surds. And that happens if y was equal to z squared times x. In other words, if y was actually x times a perfect square, then the square root of x plus the square root of y is actually equal to the square root of x plus z times the square root of x, which is equal to 1 plus z times the square root of x. In exactly the same way, the square root of x minus the square root of y is going to equal the square root of x minus z times the square root of x, which is actually equal to 1 minus z times the square root of x. Anyhow, we can get on to example 5. It's up to you whether you need to take the notes down first. Example 5 is asking us to simplify these surds. So part A is equal to 5 times the square root of 2 minus the square root of 8. And this looks a little familiar, doesn't it? Alright, so we know that the square root of 8 is equal to 2 times the square root of 2. So I'm going to skip straight to the next step. So we have 5 times the square root of 2 minus 2 times the square root of 2. So now I've got 5 minus 2 all times the square root of 2. So that's equal to 3 times the square root of 2. Done. Nice and easy, right? Okay, let's have a look at part B, where the sum is 2 times the square root of 5 minus 3 times the square root of 20 plus 6 times the square root of 45. So 5 is a prime number, so I can't reduce that anymore. So I'm going to start off with writing equals 2 times the square root of 5. Then we need to look for perfect square factors in the next square roots. So 20 is equal to 4 times 5. 4 is a perfect square, so we can rewrite minus 3 times the square root of 20 as minus 3 times the square root of 4 times 5. Looking for square factors inside 45. 4 doesn't divide into it. 9 definitely does, so that's, So 9 times 5 is 45, so that means 6 times the square root of 45 is 6 times the square root of 9 times 5. And I've chosen these numbers because they're perfect squares. This one's a little more complicated than the last one. So I know that the square root of 4 is 2 and the square root of 9 is 3. So this one's a little more complicated than the last one. So I'm actually going to do the square root expansion to make sure we don't get lost, okay? So we start off with our square root of 2 times 5 minus 3 times the square root of 4 times the square root of 5 plus 6 times the square root of 9 times the square root of 5. Okay, I think it's important I did take that extra step. Now you should know now that the square root of 4 is 2 and the square root of 9 is 3. So we have nothing to change in our square root of 5, so that's equal to 2 times the square root of 5. Minus 3 times the square root of 4 is the same as saying minus 3 times 2, so that's minus 6 times the square root of 5. And 6 times the square root of 9 is 6 times 3, so that's just 18, of course, times the square root of 5. So now I've got all like surds, and we've got 2 minus 6 is minus 4, plus 18 becomes 14. So we have 14 times the square root of 5. I'll just put a little note down here because 2 minus 6 plus 18 equals 14. Right, so they're all fairly straightforward. I mean, there's obviously a lot of room to make arithmetic errors in questions like Part B, but I have full confidence that you'll be able to work through them. So it's best at this stage you pause the video and work on questions 4 and 5 in the new book and questions 7 and 8 in the old book. And I'll see you in the summary. Okay, just as advertised, this was merely an extension of the previous lesson. So while this lesson didn't cover concepts as deep as rational versus irrational numbers, you did learn a couple of important skills and facts about surds. Alright, so to consider this class a success, you will understand that only like surds can be combined under addition and subtraction. Know how to add and subtract like surds, and know that it's helpful to simplify all surds before determining if they can be added or subtracted. Alright, good luck with that and all the pre-learning, and either I'll see you in class or the next video. Bye.